Alright, today what we're going to work on is lesson number 30, least common multiples, also known as LCM. So if you ever see LCM, remember that's the least common multiple, and reciprocals. These are important because we're going to be adding and subtracting fractions, and in order to add and subtract fractions you have to find a common denominator, and in order to get a common denominator you're going to have to be able to find the least common multiple. And then reciprocals are also important in math, and we'll talk more about that later. Okay, so let's go ahead and do a simple problem with LCM, least common multiple. You guys know what multiples are. Multiples are when you take 2 times 1 is 2, 2 times 2 is 4, and you just list them all out. You guys can probably do it really fast. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Keep going. Okay? Alright, so let's do the multiples for 3. 3, 6, 9, 12, 15, 18, 21, 24, and it keeps going on forever. Let's just go to 27, 30. Alright, so let's find some common multiples. Here we find one, and it's 6. 6 and 6, that's a common multiple. Here's another one, 12. 12 and 12 are common multiples. You guys see more? 15, 14, 18. 18 is a common multiple. Alright, so out of these common multiples, we have 6, 12, and 18. Both 2 and 3 have 6, 12, and 18 as multiples, so they have those multiples in common. Okay, so which one is the least? So you guys understand multiple, you understand common, and the next thing you have to understand is least. That just means smallest. One that's closest to 0. So in this situation, our least common multiple is 6. Any questions with that? Pretty straightforward. Alright, here's another one. Let's find the least common multiple of 5 and 8. So list out your multiples really fast. 5, 10, 15, 20, 25, 30, 35, 40, 45, and it keeps going. Alright, let's do the multiples for 8. 8, 16, 24, 32, 40, 48, 56, and it keeps going on. 64. We're not going to go forever, but I want you guys to just get a list of multiples going on. The next step is you're going to look for common ones. 40 and 40. That looks about the only common multiple out here, so we know that it's the least. So the least common multiple of 5 and 8 is 40. And keep that in mind, because we're going to do a little problem, a real-life situational problem that hopefully will make this come alive to you. But we're definitely going to use this when we add and subtract fractions with different denominators. Okay, here's a fun little problem that has to do with least common multiple. Alright, I have over here, I printed out a picture of hot dog buns and a picture of hot dogs. And we all know that companies try to make the most amount of money as possible. If you were selling hot dog buns or hot dogs, you would be trying to make money. That's the point of you working. Okay, so this hot dog bun company makes 1, 2, 3, 4, 5, 6, 7, 8 buns in a package. So you go to the store, you buy a package of buns. You get 8 buns. Okay? And this hot dog company, let's say ballpark, this is a couple different pictures, but this, you can barely see it. I'm looking at the screen right here. I can see myself as I film myself, so this doesn't look very big. But right here, the ballpark hot dogs comes in a pack of 1, 2, 3, 4, 5 hot dogs. Alright, so say you want some hot dogs, you go to the store, you buy a package of buns, you get 8 buns, you buy a package of hot dog, you get 5 hot dogs. So you're thinking, well, I'm going to have 3 buns left over, so let's buy another package of hot dogs. So 5 times 2 packages would be 10 hot dogs. Well, now you have 10 hot dogs and 8 buns, and you're thinking, oh no, now I'm going to have 2 hot dogs left over. I need some more buns. So you buy another package of buns. 8 times 2 is 16. Oh, now you have 6 buns left over. So as you can see, this is basically a common multiple. You're trying to see what's the least amount of hot dogs and buns I have to buy until I have an equal number of hot dogs and buns. And that equal number is going to be your least common multiple. So let's go out. And if you go up again, if you buy another package of buns, you're going to have 24 buns. Couple more packages of hot dogs, 15 hot dogs, 20 hot dogs. So now you're going to have 20 hot dogs and 24 buns. You're going to have lots of hot dogs and buns. You are definitely gaining weight. So how many do you have to buy? We're going to go up to 32 because in this situation, if you had bought 3 packages of buns and 1, 2, 3, 4, 5 packages of hot dogs, you're going to have 1 hot dog left over. At that point, I would just throw the hot dog and be like, I don't care, I'm not buying anymore. But that's not the math problem. We're trying to figure out how many we'll have to buy. So 40, let's see how many packages of hot dogs we'll have to buy. 5, 10, 15, 20, 25, 30, 35, 40. Finally, our least common multiple is 40. But in doing so, you will have bought 1, 2, 3, 4, 5 packages of buns. Let's say 5 buns. And how many packages of hot dogs? 1, 2, 3, 4, 5, 6, 7, 8. So that's 8 packages of hot dogs. Okay? So you need to buy 5 packages of buns and 8 packages of hot dogs in order to have an equal number of buns and hot dogs. In that case, you're going to have enough for 40 people. So that's pretty much our class, and a couple people will eat 2 hot dogs, and so 40 people coming to your house. We're going to have a party. And so the reason why they do that though is because they know that if they do it with a ratio of 5. If they do this with a ratio of 8 hot dog buns to 5 hot dogs, that the companies are going to make more money. Because instead of only having to sell 1 package for each, you're going to have to buy more hot dogs and buns. They've done studies and they see that it works that way. Alright, let's really quick review how to multiply fractions. When you multiply fractions, which is different than adding fractions, you multiply straight across. 3 times 2 is going to be 6. 4 times 5 is going to be 20. Okay? Very simple. Multiply straight across. Okay, what if you have to multiply a fraction by a whole number? Well, remember the magic 1. Whenever you have a whole number, you can put that over a 1. Okay? So this is 2 times 2, which is equal 4. 1 times 5 is 5. So where did I get the 1? That is I call that the magic 1. Anytime you have a whole number, you can put it over 1. Okay, let's multiply 2 times 1/2. Magic 1 magically appears, allowing us to multiply. 2 times 2 is 2. 1 times 2 is also 2. Remember, anything divided by itself, top divided by bottom, we always do top divided by bottom, is going to be equal to 1. Let's do another one, and I want you guys to look for a pattern between problems number 5 and 6. Let's do 3 times 1/3. Notice this is 2 times 1/2, 3 times 1/3. Notice I have a 2 as a whole number and 2 as a denominator. 3 is a whole number and 3 is the denominator. Okay? Magic 1. 3 times 1 is 3. 1 times 3 is 3. And we know top divided by bottom is 1/2. Basically what we're doing right here is we are multiplying by the reciprocal. Okay? And I'll talk more about that in a second. Alright, let's go ahead and talk about the reciprocal. What is a reciprocal? In my head, reciprocal just means flip. Okay? So all you got to remember is whenever you see the word reciprocal, that means you just flip the fraction. Alright, so if the fraction is 2 over 3, if we want to find the reciprocal of that, that would be 3 over 2. Notice, the numerator becomes the denominator, and the denominator becomes the numerator. We're going to use this a lot. You'll use this a lot in algebra, higher level math. This is important to remember. Okay, so what would the reciprocal be of 4/5? Give you a second Pretty simple. 5 over 4. You just flip it. Reciprocal means flip. Now it gets a little bit more difficult when you have a whole number. Okay? What if we have 2? What's the reciprocal of 2? Well, remember, you can always put it over 1. Put a magic 1. The reason why I call it magic 1 because it magically appears. Whenever you have a whole number, you can put it over 1. So 2 over 1, when you flip that, would be 1 over 2. So the way that would look is the reciprocal of 2 is 1/2. Let's do another one of those. What is the reciprocal of 3? Well, in that case, it would be 1/3, because remember, you always have a 1 there. And if you flip that, it'll end up as 1/3. What if we want a reciprocal of 1/4? Well, that will be, reciprocal of 1/4 will be 4 over 1, which is equal to 4. So the reciprocal of 1/4 would be 4. Okay, so there's a little bit on reciprocal. Okay, so let's go ahead and do example number 7. How many 2/3 are there in 1? Basically what you're asking is how many times do you have to multiply 2/3 in order to equal 1? In order to do that, you just multiply it by the reciprocal if you want to get 1. Remember earlier we were talking about a little bit about this, like top divided by bottom equals 1. So let's go ahead and do this. This box is a little small. Let me make it bigger. So what's the reciprocal of 2/3? Well, you just flip it. That'd be 3/2. Notice we're multiplying by the reciprocal in order to equal 1. Does it really equal 1? Let's check that. What is 2/3 times 3/2? 2 times 3 is 6. 3 times 2 is 6. Wait, this 6 over 6 doesn't equal 1, or does it? Remember, top divided by bottom is going to be equal to 1, so it checks out, it works. So if you multiply by the reciprocal, you're going to be able to find 1. Okay, this is the last problem. 5/6 times what number is going to equal 1? So it's kind of like a little equation. And remember, we know that if you multiply by the reciprocal, it's going to equal 1. So what's the reciprocal? This is basically asking you, what is the reciprocal 5 over 6? And we know that reciprocal means flip. So if you're going to flip it, whatever's on top is now going to be on bottom. Whatever is on bottom is now going to be on top. Okay? So 6/5 is going to result in 1. In order to prove that, you just multiply out. Let's do 5 times 6 is 30. 6 times 5 is also 30. What's 30 divided by 30? Anything divided by itself is 1. Okay, guys? So you guys are doing some higher level math. Pretty soon you're going to be using this for algebra. Awesome job. Hopefully that makes sense today.